right, we are looking here at the week 2 sphere response that you had to do. This is the first set, so the stuff that was due Tuesday. This is the first question where you had a graph of f prime. It says the figure above shows this graph. It's the derivative of function f over this interval. The graph of f prime has a horizontal tangent at -3, at 2, at 5, and then it also has a vertical tangent line at 3, so that's a little bit different. So I just draw those little sketches in there to remind myself that they told me that. Part A, find all the values of x of which f attains a relative minimum. So probably what I would do, I see actually parts A and B have to do with relative extrema, right? I would go ahead and create a sign chart for me right off the bat and indicate any places where f prime equals 0, which is -5, -1, or does not exist. Now it also does not exist at 3 because of that vertical tangent line, so that is important to point out. Okay, and then I would go ahead and fill this with the signs of f prime on those intervals. So it's positive here, it's negative in here, it's actually positive in these two intervals, oh, and it's positive there too. Okay, so that's just some information that's going to help me answer parts A and B. So real quickly write the answer to part A. Says we've got a relative minimum, right, wherever f prime goes from negative to positive. So part A is at x equals -1 because f prime goes from negative to positive. Okay, don't try to come up with that any other way. Don't say any other thing other than this. Don't talk about the slopes increasing or decreasing or whatever you think you're saying. Never use the phrases increasing and decreasing, okay? I want you to go ahead and just say f prime goes from positive to negative. Part B, relative maximum then has to be where f prime goes from positive to negative, so that's at -5 because f prime goes from positive to negative. Okay, no other places, of course, because there's no other sign changes. Okay, part C, final values at which f double prime is negative. So another way of saying this, right, is I'm looking for places where f prime is decreasing, right? That would imply where f double prime is negative. Okay, so that implies on the original graph f that f is concave down. But of course, remember, this is f prime, the graph that you're looking at, so you're looking where this guy's decreasing. So it's decreasing from here to here, right? So I'm going to say -7 to -3. It's also decreasing from 2 to 5. And then it's strange that it doesn't say any other places here. So I would probably put this information by my answer for part C and say f double prime of x is negative where f prime is decreasing. Okay, so they know that that's what you were looking for, even though it doesn't say justified. It's good enough. And then part D is where a lot of you guys had blanks, right? So D says at what value does f attain its absolute max? So here's where we're analyzing the area under the curve, right? So I need to consider endpoints and any relative maximums as potential places where I could have my absolute max, right? So in the past, right, we've done a chart, -7 to 7, and the only place where I have a relative max, as answered in part B, right, is at -5. So I'm going to consider these places. You don't know anything else about f other than this is what its derivative looks like. So I'm going to I can't come up with sheer numbers for these here, right? All I can kind of do is compare the area under it. So at -7, let's say that's kind of like our starting point. Let's say we have nothing there, right? So really then my absolute maximum has to occur at one of these two places. So my absolute max at, or the area that I've accumulated, right, the amount will be 0, which is what I started at, in this much area. Now we have no y values along here, so I have no idea how much this actually is. You know, maybe this is 100 over here. I have no idea. So I'm just going to kind of keep that amount in my head, and then I'm going to kind of compare the magnitude all the way at the end here to that. Okay? So if I'm looking at f of 7, right, I'm going to kind of compare all of this orange area then would be f of 7. So all of this, coupled with that, right, and then this portion here that's below the x-axis would kind of take away from this area. So let's say this blue area kind of cancels out maybe all of this. Does that look reasonable to you? That means f of 7, the amount that that would be, is whatever number all of the rest of this orange area is, right? And wouldn't you say that all of this orange area here is more area than is right here in this little triangle, which is what we're comparing it to? Okay, I think so. So we're going to go ahead and say here that my absolute max is at x equals 7 because I have more area there than I had before. So what I would say, I would show this chart, right? This is showing all the candidates, the possible places where my absolute max could exist. And then I would say my absolute max is at x equals 7. And I would say because the value of the integral from, let's say, -7 to 7 of f prime, right, is greater than the integral from -7 to -5 f prime of x dx. And then that would show that you compared the area underneath the f prime curves and that this one is more. So that's where your absolute max has to be, right? Super impressive.